Hello viewers, today we'll be doing a classification of image of 2020 for Amritsar city using Google Earth Engine. The code set that we'll be using will do the classification using classification and regression tree, that's CART method. So I have a code which I've uploaded to GitHub, the link is provided in the description. You just go and copy this code and paste it in your GEE profile. And what you do next is you need to import the Landsat image collections. For that you simply go to the search bar and put in Landsat 8, press enter. So you'll be presented with a lot of options of Landsat 8. You simply go and choose the collection one, tier 1, TOA reflectance, that is top of atmosphere reflectance. We'll take this, click on import, and there will be it will be imported into your imports, and then you rename it as Landsat 8 or whatever Landsat collection it is for. The second import that is very important and crucial to this is your boundary, if any, to which you want to clip your images. So for this case I have the municipal boundary of Amritsar which I had in my assets. You simply import it from here and then rename it. So that's all for the imports. Moving on to the code itself. So you'll see here that I have taken the Landsat 5, 7 and 8 image collections, and then I filtered them according to the date and the filter boundary, which for my case is Amritsar, and then according to the cloud cover in that imagery, which I have taken as 5%. So when I print this variable, oopsie. Yeah, so when I've given a command to print this variable, you'll see that in the console side of your code, you'll be presented with a huge print which will have all the images for that year. See, it's compiling. Yeah, so it has loaded, and when you click on this, you'll see there's a lot many 132 features in this. Each of that is an image. We are simply interested in image of 2020, which will be the last one, I guess. Yeah, and since I'm trying to make my images consistent around March, I'll take this image of March, which is this one. So you simply click on this and copy the address. Now go to the code. These are all the functions that we'll be using. Go to the code and make a new variable for image of 2020, and then just paste it there. So this image is for 2020. Now we have created a variable for 2020 image. We need to view the image too. So I'll remove the comments from the older part. I'll put the comments on. What we'll do is we'll simply rename this as 2020 because that's how we defined it up there. Then run this. Once this has run, I'll be back. Positive. Yeah, so as you'll see here, the code has run and the image is generating. This bar will show the progress of how much of the image has been generated. So for the image of 2020 that we took, you will see that layer shows at 2018. That is because we forgot to change the name of the layer to 2020. Anyway, that doesn't matter. What you have to do is check the image for any cloud cover over the area of interest that you have. In my case, I see none, and since the image of March, it is fairly, and because it is from Punjab, it is fairly green at this point of time. You'll also notice that all the greens are shown as red in this image. This image is a false color composite, and what we do is in this case we show NIR as red, red as green, and green as blue. So this image is perfectly fine. We'll proceed with the classification now. For this purpose, what we do now is uh, you go to the geometry imports, add a new layer, and for my case I'm following a nomenclature that is all the urbans are marked as 1, the greens are marked as 2, water is marked as 3, and barren land is marked as 4. You can take your preferred nomenclature for that purpose. We'll call this urban 2020. Convert this to a feature collection, choose the color of your desired color, add a property, name it land cover, give the value of 1 for land cover of urban. Press on OK. Now what we'll do is zoom in to the image. You could also use this feature which helps you in viewing in a large screen. Zoom into the image and look for pure pixels of urban. In my case, I want to take as many samples of urban I can, so I guess this is a good spot to begin with. I generally use points or rectangles. Here I'll use the rectangle tool. So this looks like an urban patch, and it is many times not possible to have purely urban patches because of tree cover present in urban building blocks. But for my case, I guess it's fairly good. You can see all these pixels, they have a bit of reddishness to them. That's because of the tree coverage. So take as many samples as possible, but I'd suggest take at least 10 samples and at max of 30 samples. You can tweak on your own and try to play with it, but Google Earth Engine has this weird policy of not having more than 512 KB of data, so that limits the amount of points that you can have. Okay, so let's take this one patch here. You could also maybe move to satellite imagery and see for yourself if it is purely urban or it has mixture of barren in it or even tree cover. So this is fairly urban in nature. Don't take those red pixels, they will mess up with your green cover data. Yeah, so I'll pause the video for now, take more samples of urban, and then I'll be back. Yes, so I'm done taking urban. As you can see, I've taken 11 polygons, no points this time. Now I'll move on to taking water samples because I see water in this picture already. Yeah, so new layer, go to settings, change the name, settings. This is water 2020. Change the feature collection, add the property of land cover, give it a number for 2, number of 2 for water. Yeah, so here we are with water 2020. Now as you can see in the picture, this is the Gurudwara which has water body around it. So we'll try to pick pure samples of water because as you see, some pixels are overlapping with water boundary and the non-water boundary. So I prefer to take points for this case. So this looks fairly water to me. This looks like water. The rest are of weird colors, will avoid that. Take this sample now. So here we can try and take a square maybe, or if possible this. Yeah. So it's not necessary that you take 10 samples all the time. Try to do it with fewer samples, but many times it's not possible to get the cleanest of results with fewer samples. In such cases you'll have to go for further samples. So here we have a canal. I guess we'll have water in it, but as you can see, I guess there is some overlapping or grass surrounding it, so we don't have pure water samples here, so we'll leave this. Similarly, I'll be back after classifying my barren samples and the green samples. Oh, it's my bad, guys. Green was at number 2 and water was number 3. So I assume that was a mistake. My bad. So you can anytime go to the geometry imports and change the setting for that given layer. Now I'll be classifying my greens. I'll take the rectangle because it's easier to do it with that. This looks fairly green. This one's green too. Try to take different types of greens, like different samples of greens, because not all red that you see is of the same color or texture. We'll not be taking this one, this pixel here. It's a crop field that has been cut probably. Yeah. See, you'll have such pixels wherein, like for example, the cantonment area you have here, it's quite green. So you'll have a lot of mixture between urban and green and pixels in between. So try to avoid such samples, but uh, sometimes you have to classify them separately and then replace them as urban or barren or whatever major class that they fall under. So I'm done with the greens, not there at 10 yet, but I'll stick with this. I guess I've gathered enough samples. Yeah, so now we'll be classifying the barren lands. So since this is a March image with heavy soil moisture, it's difficult to find perfect samples of barren, but let's play our bets on these samples. Okay, so this field is perfectly barren. Yeah, so let's try to run with these samples, and for this purpose what we do now is go to the coding section. Now as we did, we made 4 different classes. We'll just copy this into notepad, replace 2018 with 2020. And just click on replace all. Now you copy this back to the code. So this function classifies your image with the samples you had for 2020. Now just copy the line above, paste it here, replace all 2018 with 2020. What this line of code does is it replaces all samples of urban of 2018 to that of 2020. So now hitting on the run button. Here we go. Always remember to save before you run. I guess my PC is stuck. I'll be back when it has run and has some output to show. Oh yes, it will show no output because we have not put the final function to use, which is LULC nadir, which actually displays the classified image. So here too, you simply go and replace all 18 with 20. So what the code here in classified 2020 new does is it takes all urban of classified 2018 old and replaces it into classified 2020. Now we'll give it a run. So you see we have a new layer here named as LULC. Let it load. Yeah, so in the image you can see that the classification is done fairly well. It's loading. And it has even captured some of the water features over here. Yes, so in this image you can see that there's a lot of barren patches all over. That is maybe because of a bad sample taken for barren. So you can always go back and refine your samples. So that was all for this video. Thank you.